This video covers section 1.5, quadratic equations. A quadratic equation in X is an equation that can be written in the standard form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a cannot be equal to 0. What makes this equation quadratic is the x squared term, so if that leading coefficient is 0, it makes the equation linear. So you can never have that a term missing. B or C, however, could be missing. This section we cover 3 different ways to solve a quadratic equation. We can use the factoring method, or a square root method, or completing the square, which leads to the quadratic formula. One of the ways we can solve quadratic equations is by factoring. The factoring method uses the zero product property. If the product is 0, then at least one of its factors has to be 0. For example, if you have a times b equals 0, then either a is equal to 0 or b is equal to 0, or both of them are simultaneously 0. However, be careful, that doesn't work if you have a times b equals a number. Okay, so if you have a times b equals 4, a is not equal to 0, b is not equal to 0. That doesn't make sense. The only reason that the other one works is because we're really dividing both sides by a. So when you divide ab over a's cancel out, you get b. 0 divided by a is 0, and 0 divided by any number is 0. So it's got to have a 0 on the other side. Which takes us to our first example. If you solve x squared minus 6x plus 16 equals 0, you have to have that equal to 0 for factoring. So if you can factor this, which becomes x minus 8, x plus 2, you can solve for the two factors x minus 8 equals 0, x plus 2 equals 0, so you get x equals 8 and x is equal to negative 2. You have to have it in standard form, so make sure you have equal to 0 when you're using factoring. Look at this example, x squared plus x minus 20 equals 0. The factors for that are x minus 4 and x plus 5, so you get x equals 4 and x is equal to negative 5. Once again, it had to be in standard form. This problem, you have 9p squared is equal to 24p minus 16. Notice we're not equaling 0 anywhere. So the first thing you have to do is put it in standard form, bring everything to one side. So you have 9p squared is equal to 24p minus 16. So you get 9p squared minus 24p plus 16 equals 0. If you factor that, you get 3p minus 4. 3p minus 4 equals 0. Since it's multiplication, you can split it. 3p minus 4 equals 0. Since it's the same, you're going to get the same p-value for both, 4/3. If you get repeated p-values like this, they're called double roots or repeated roots. That means you have got the same solution twice. Another method we can use is square root method. Square root method is used for quadratic equations that have the linear term missing. Linear term is the middle term, the one that has the variable to the power 1. So if you have ax squared plus bx plus c equals 0, it's the x term that's missing. If that's the case, it's easier to solve these by just moving the constant to one side and taking the square root of both sides. And whenever you take a square root down, remember to always put plus or minus. And at the end, you solve for the variable. For example, here you have y squared minus 147 is equal to 0, and they want you to use the square root method. So first thing, take the constant to the other side, so if y squared equals 147. Now you want to get rid of the square, so you take the square root of both sides, but don't forget the plus or minus. So y is equal to plus or minus square root of 147. You want to simplify 147. 147 is 49 times 3, so that's a perfect square, so you can bring out the 7. So y is equal to negative 7 root 3 and positive 7 root 3. Another example you have is v squared minus 64 equals 0. The fact that the highest degree of this polynomial is 2 makes it quadratic. Notice v to the power 1 is missing, so that makes it the linear term missing. So we can use the square root method. Take the constant to one side, so 64. And if you take the square root of both sides, you get plus or minus square root of 64, which is plus or minus 8. The square root property can also be used if you have a variable with other properties in it. For example, if you have x minus 2 squared equals 16, the object here is to solve for x, so you can take the square root of both sides And so you end up with x minus 2 is equal to plus or minus 4. And then you want to solve for x, so take the negative 2 to the other side. So you get 2 plus or minus 4. So you get 2 plus 4, which is 6. 2 minus 4, which is negative 2. The next technique that we do is called completing the square. X squared plus bx plus c is equal to 0. For completing the square, the first thing we have to make sure of is that our leading coefficient, which is a, should be 1. So if you have a number in front of it, like 3 or 2, always divide all terms by that number so that a becomes 1. Then what you want to do is take the constant to the other side, so negative c, okay? And so you're left with x squared plus bx is equal to negative c. We are trying to solve for x, but the way we do it is we try to complete the square on the left-hand side. Since we have x squared plus bx, we want to add a b over 2 squared to both sides. If you do that, the left-hand side becomes x plus b whole squared, and the other side you get negative c plus b over 2 whole squared. And then we want to use the square root method to solve for x. Now this method makes more sense when we work out a problem, so let's work out a problem. So, the problem here is y squared minus 10y minus 3 is equal to 0. So notice your leading coefficient is a equals 1, so that's good. Take the constant over to the other side, so negative 3, move it to the other side, so it becomes a 3. Now your b here is negative 10. So what you want to do is add b over 2 squared to both sides. So negative 10 over 2 squared to this left, negative 10 over 2 squared to the right. Now negative 10 over 2 is just 5. 5 squared is 25. So what we just did here is add 25 to both sides. Now then, on the left-hand side, y squared minus 10y plus 25, notice you can factor that. That's just y minus 5 squared. Usually it always becomes a perfect square, so you really want to always, that's why we use b over 2. So once you have y minus 5 squared is equal to plus or minus 28, you want to take the square root of both sides. That's where that plus or minus comes in. So if you take the square root, you get y minus 5 on the left, and you get plus or minus 28, which is 4 times 7, so 2 root 7. The last thing, take the 5 over, so you get 5 plus 2 root 7 and 5 minus 2 root 7, and you're done. Let's look at another example. X squared minus 4x minus 1 equals 0. Notice the leading coefficient here again is 1. So we can go ahead and get started. Take the constant to the other side, so x squared minus 4x equals 1. b here is negative 2, so we want to add negative b over 2 whole squared to both sides. So negative 4 over 2 squared on the left, negative 4 over 2 squared on the right, which is really negative 2 squared, which is 4. So you get x squared minus 4x plus 4. So if you factor that on the left, you get x minus 2 squared. On the right, you get 1 plus 4, so you get 5. If you take the square root of both sides, remember, got to add plus or minus to the right. So you get x minus 2 equals plus or minus root 5. Take the 2 over, so you get 2 plus root 5, or 2 minus root 5. Now what happens if your leading coefficient is not 1? If your leading coefficient is not 1, then what you want to do is divide all 3 terms, or all 4 terms, by 3. So 3 by 3, negative 12 by 3, 13 by 3, and 0 by 3. Then you get x squared minus 4x plus 13 thirds is equal to 0. Take your constant to the other side, so you get negative 13 thirds. Then you want to add negative b over 2 whole squared to all of it, or b over whole squared. Your b happens to be negative 4 here. So negative 4 over 2 to both sides. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So we added 4 to both sides. So if you add 4 to both sides, on the right-hand side you get negative 13 thirds plus 4. Add those fractions, because you have 2 constants. 4 is over 1, so multiply 3 over 3. So you get negative 13 plus 12, which is negative 1/3. And on the other side, because we got x squared minus 4x plus 4, we get x minus 2 squared. Go ahead and take the square root of both sides. Put a plus or minus in. Since we have a negative number, you get 2 plus or minus square root of 1/3 I. Two x squared minus 4x plus 3 equals 0. Notice the leading coefficient is not 1, so the first thing we have to do is divide by 2 all of the terms. So we get x squared minus 2x plus 3 halves equals 0. Take the constant to the side, so you get negative 3 halves, and add b over 2 squared, so negative 2 over 2 squared for both sides, which is 1. So you get x squared minus 2x plus 1 on one side. The other side you get negative 3 halves plus 1. So if you go ahead and add the fractions, negative 3 halves plus 1, you have to multiply 2 over 2 on the right hand side, so you get negative 1 half. On the other side you get x minus 1 whole squared. So if you take the square root of both sides, you get x minus 1 is equal to plus or minus square root of negative 1 half. If you take the negative square root of 1 out, it's an I, so you get 1 plus or minus 1 over root 2i. You can rationalize your answer, so notice that's the same thing as 1 plus or minus root 2 over 2i. The last thing we can do is talk about the quadratic formula. This is the last way we can solve quadratic equations. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Make sure when you use this that you have a standard form equation. We can always figure out how many solutions we're going to get by looking at the b squared minus 4ac component. B squared minus 4ac is called a discriminant. And if it's positive, you get 2 distinct real roots. If it's equal to 0, you get 1 real root, which is a double or a repeated root. And if it's negative, you always end up with 2 complex conjugate roots. So if you have 4x squared minus 2x equals 7, bring it to standard form, so make it equal to 0. Okay. Once you have that, a is 4, b is negative 2, c is negative 7. So if you use the formula, x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. You get 2 plus or minus 4 times 4 times negative 7 all over 2 times 4. So if you simplify it and add your like terms, you end up with 2 plus or minus square root of 116 over 8. 116, you can simplify that as 36 times 3, so you get 6 root 3. Notice in the numerator there you get 2 and 6, so you can factor out a 2, which leaves you with 1 plus or minus 3 root 3. Now the 2 cancels the 4 in the denominator, so your final answer could be 1 plus or minus 3 root 3 all over 2, and you can separate the two fractions. T squared plus 2t equals 1. If you try the quadratic formula for it, always bring it to standard form first. It's got to equal 0. A is 1, b is 2, c is negative 1. So you get negative 2 plus or minus 4 minus 4 times a, which is 1, times c, which is negative 1, all over 2. So you end up with negative 2 plus or minus 2 root 2 all over 2. You can factor out a 2 and cancel it with the bottom. So you get negative 1 plus or minus root 2.